Vale. Hi, welcome to our webinar. Uh, well, I will restart again because we were waiting for the last attendees. Good morning. My name is Jorge. I am here to present you our technology, and to give it another angle, we will do it, or we compare the spot monitoring or spot testing of the partial discharges versus the online monitoring of the partial discharges. Along the webinar, we will proceed and follow these points. First, we will talk about us. Secondly, we will talk about what are partial discharges and how can we detect them. Afterwards, we will show you how we do spot testing. Afterwards will be how we do the continuous monitoring, and case studies will follow. By the end, we will show you a summary of how the spot and how the continuous are a comparison, cost comparison, and detection percentage comparison. Uh, okay, well, a little bit about us. We are Ampathimon. We have been working mainly in Europe and the US. These are all our clients. Mostly we work with the major utilities in the US, Canada, and rest of Europe. Currently, we are expanding and we are improving our operations in Asia. And well, this is a little bit about our numbers. We are monitoring more than 150 transmission lines. Pues nada, el único que ha entrado se ha pirado. The only guy who has entered has left. Anyway. Hi, welcome. We'll wait for 1 minute more for the rest of the attendees, and we will proceed to start the webinar. Okay. Uh, Good morning, everyone. Uh, my name is Jorge. I will present today the partial discharge, how we do the partial discharge monitoring, and we will compare it between the spot testing and the online monitoring. First of all, this is the content we will follow along the webinar. First, we'll talk about us. Afterwards, we will talk about what is a partial discharge and how can we detect and how do we detect them. Afterwards will come how we do spot testing. Next, how we do the continuous monitoring will follow, and we will show you some case studies, and we will present you a summary on how we do. I mean, how does the spot and continuous influence in the amount of detection or percentage based on our experience, and also how we'll talk about costs mostly in a gross number in percentages. Okay, so we're Ampasimon. We are a European technological company. We have our headquarters in Liège, in Belgium, in Madrid, where I'm based, and in Atlanta, in USA. We work with major utilities in Europe and in North America, mostly, in America, sorry, and we are currently expanding our operations in Asia also. A little bit about our numbers. We monitor more than 150 transmission lines and 15,000 circuit of sorry, 15,000 kilometers of circuits are monitored also. More than 800 assets, 80. Our company, we are 80 people, more than 80 people. We have more than 60 customers worldwide, all of them major utilities, oil and gas companies. And we have more than 12 patents in 20 countries. Also, these are mostly our business lines. We have the DLR business and the condition monitoring. Today, we will talk about our business line, the condition monitoring. So, what are partial discharges and how can we detect them? A partial discharge is a small electrical spark that happens inside the insulation materials of high voltage equipment, such as cables, transformers, GIS, or motors. It occurs when a tiny part of the insulation is weak or damaged, allowing electricity to jump through a small gap or void. And well, I like to think of it as a small lightning strike happening inside the insulation. These small sparks don't cause immediate failure, but over time they weaken the insulation, leading to serious breakdowns, short circuits, or even complete equipment failure. Here we have the pictures on how they evolve. Here we can see, or we call it the PD3, and then we have the final breakdown, which causes, for example, a transformer can create a fire, and then, well, fatal consequences. Please feel free to ask any questions in the chat. We will be solving them in the meanwhile, or you can ask in the end of the meeting. Okay, so also there can be another comparison, which is the online and offline PD monitoring or PD testing. We are mainly focused on the online monitoring. We can cover parts of the offline, but we are mostly focused in the online monitoring. Why? First, because it's non-invasive, non-destructive. We can detect incipient problems. We can, I mean, with the online, we are monitoring while, well, it's not in a, how can we say, in a bubble condition. It's in a real operating condition. So we are detecting what is happening in real time. It's not laboratory. And we can, and also there is no need to de-energize. So it will not affect practically the operating procedure of the plant or any installation. Whereas in offline, it's completely the opposite. A service stop must be needed. You are not you are in a bubble condition, so you don't see all the noise that any machinery or any other assets can generate. It's just, how can I say it? It's real, of course, but it's a bubble. It's a condition of our laboratory, not a normal operating one. How we do spot testing? Well, this is really simple. We monitor high voltage underground cables. We connect in the terminations of the cables and in the joints, and we monitor the PD along the cable. We are capable of detecting the exact location of the PD, if it's in the terminations, if it's along the cable. And of course, if it's spot monitoring, we send people or even our partners and people with our equipment and measure and plug into the system, into the asset. Same happens in the distribution system or substations in the GIS or transformers. In the transformers, for example, we use antennas in the fuel tank to detect any PD activity. Also in the GIS, we use normally manufacturers have their own sensors installed in the GIS, and we just plug in those sensors and monitor them with our data acquisition unit. And in rotating machines, we, as you can see in the diagram, we connect in every phase. So basically, they use our spot testing product. It's called the PD Pico, which is this device. This is the data acquisition unit, and here we have the HCVT sensors, sorry, and other devices, cables, etc. We plug into the sensors, we retrieve the data, and this goes to our AI platform, which is called PD Solver, at which we detect all the PDs, clusterize them, as you will see later, and submit the report to the client. Whereas in continuous monitoring, we don't need to send anyone. We just leave our smart visor, which is our data acquisition unit. We plug them in the sensors, TEVs, HFCT, and coupling capacitors in the rotating machines. We retrieve the data. It's sent to our PDI, okay, which is the AI tool for continuous monitoring, or we can, it can be in an Amazon Web Service cloud server, or it can be in a local on-site server in the client's facility. And from there's where we have our PDI, and from the PDI we send the reports to the SCADA of the client. Okay, so afterwards, as I told you, we will talk about case studies. Our first case study, it's a spot testing experience on a 12 kV cable system. This is, we cannot say names of clients, of course, but it's one of our major utilities in Europe that also, well, it's the transmission division of one of the major utilities that operates in Asia and worldwide. And well, here the funny thing is that after 10 minutes of spot testing, we detected just in 10 minutes, we detected 9 internal PD defects in 270 meters long cable. As you can see, we can detect the PD activity along the distance. Here you have the millivolt and the meters in the distance. So in case they have to do works or something, they don't have to open the whole cable and put it open air. They just have to go directly to the spot. In this case, we monitor with 2 people, one in one side and one in the other, to find the exact locations. Next case study. This is one of the biggest oil and gas companies in the world. And what happens here is that we are temporary monitoring a 66 kV cable system. Since it's temporary, we've been monitoring the cable for 4 days. And in 4 days, we detected in a 420 meter cable. Sorry, no, it's in a 1.17 kilometers. cable. And we detected in the joint that is located in the 420 meter, we detected a punctual PD activity. But there's a funny thing here. The amplitude changes or increases while the load decreases. So, well, in this case, we could solve the matter because it was an initial stage of the defect, but well, we could detect it in just well, the correlation is quite strange because the less load in the cable, the more amplitude of the PD. But that's a further and deeper knowledge about PD that we can share later. Next case study. This is another one of our major utility companies that originally comes from gas sector. In this case, we monitor here a 220 kV cable system, and what we do here it's a continuous permanent monitoring. In this case, we did a continuous permanent monitoring, and well, here the funny thing is that the PD activity increased a long time, or no, it didn't increase. It just appeared temporarily and randomly, and we found out that in the terminations there was moisture, and we said, oh, maybe it was raining, and moisture or water got into the termination, and it was that. We correlated and could prove the causality of the PD because of the rainfall. We monitored that the rainfall activity was happening in certain times, just when it coincided exactly when the rainfall and when the PD occurred, as you can see here in the table. Um, Another case study. Here we are monitoring, spot monitoring, a 66 kV cable termination. This is also in one of our, well, European biggest oil and gas companies in the world. Here we did periodic spot testing for 5 months. One spot testing in 1 month and one in each month, as you can see here. Here, we were monitoring the terminations at the transformer, and we found out that there was an increased trend of the PD activity. The activity was higher every month. Well, we found out that it was a leakage in the transformer. There was a leakage that was affecting, and well, before it caught fire, we could detect it. And this was in a refinery. Also, next case of study. Well, here, what I want to explain is that we did our continuous monitoring, and thanks to our AI platform, we can detect from the beginning of the installation till the end. We can detect every type of activity. And here, as you can see, there's a lot of intermittent trend activity. Here, we have a constant behavior. Later, there are less things happening, but it's still constant. But then it seems that it becomes quite random between this space, and then it becomes constant again. Well, these things you can only monitor them once you are monitoring continuously. And in this case, in this facility, we monitor with HFCT in a switch gear. And also we monitor the temperature in the meanwhile. We can correlate any type of data, temperature, humidity, pressure in the conductor, and correlate it with the PD activity, thanks to the HFCT sensor. And well, this is another case of study. This is one we are really proud of. This is in one of the Europeans airport. I forgot the name in English. One of the airport management companies, airport authority. Well, here we are monitoring 4 kilometer cable from A to B, from GIS to GIS. And we are monitoring terminations, joints, everything in every meter. Well, the funny thing here is that the contractor did the installation of all the cables. And in the SAT, in the site acceptance test, everything was perfect. But suddenly we we just saw that in time, well, there were some failures, so we started to do the authority called us to do the measurements, and after the second week of the set acceptance test, we start to detect PD activity. So we did a continuous monitoring. Here we have the first PD activity, and then we detected and we found out 9 events occurring a long time. Every line is a month. So the first month, from 0 month to the first month, we detected 2 PD activities. From the first to the second, we detected 5 PD activities. From the second to the third, 2. After notifying this to the authority, they requested the contractor to start doing works to solve the PD activity. As you can see here, everything was solved afterwards. But thing is, well, it's explained afterwards. Thing is that we obtained and we managed to get all this from raw data gotten from our sensors. We clusterize it and we analyze in every phase, and we detect the PD trend. And this is a picture of the cable. After just 2 weeks of installation, this thing happened. Imagine if it wasn't detected. And well, to summarize a bit, here what we want to explain here is how every PD detection strategy may affect. And based on our experience in each PD or strategies like doing nothing from site acceptance test to permanent monitoring, how many failures we detect along the 30 years life cycle of the asset, and between its type of strategies, how will affect the monitoring, how will affect, and also how will be the cost compared to the permanent monitoring. So first we have the first strategy, which is nothing, doing nothing. So you don't detect any failures, you just apply corrective maintenance once you have the failure. And of course, the cost compared to continuous monitoring is just 0%. Then we have the site acceptance test. If it's only a site acceptance test, in a 30 years life cycle, you can only detect the 2% of the failures of the whole life. And you detect it in the infant phase of the life cycle. And compared to the continuous monitoring, it's just the 13%. It's only the 13% of the price. But you are only monitoring one small time. Also, afterwards, we have the spot test every 5 years. One test done every year. You detect 15% of the failures. But you are just testing 6 times, and you avoid detecting all the random events that occur along the year. So you just detect the 15%, and the cost compared to doing an online continuous monitoring will be only the 13%. Same happens with every 3 years, 3 years, 10 times, you just detect 30%, and the cost compared is just the 21% of the total of a continuous monitoring system. Afterwards, we have the spot test every year, 30 times you detect. Here you can detect have 50% of the periodic testing of the PD activity. But as you can see, it's coming closer to a continuous monitoring system. So it's a 64% of what could cost the permanent monitoring. And then we come temporary monitoring once in a year. You get 95% of the failures in the lifetime, but it's much more expensive compared to our continuous monitoring system. Well, the permanent monitoring system, you detect all of them because you are from the beginning to the end, and you detect all PD activities. And of course, it will be the 100%. You can remind you that you are feel free to ask in the Q&A part, and we will be solving your questions while we are in the while I'm talking. My companion will solve every question. Well, at last, the summary. Uh, Advantages and disadvantages. We talked about money, we talked about percentages, but we cannot forget this advantages and disadvantages matrix. So we have advantages of the spot testing. It's easy to perform. You just go there, plug, and detect it. And you get quick results. Yeah. But the disadvantage is that you only have a snapshot. You only see a small part of the time. You don't see any random events. You just see the picture of that moment. There is no automatic warnings in the system. Of course, once you do spot monitoring, you have to send people to the field, or you need to use people and put them there, and that's a cost. Also, the spot testing shutdown is required if there's need to install sensors. Mostly, the sensors are already installed, and you just have to plug yourself to a link box and make the readings. But if there are no sensors installed, you have to shut down, de-energize the system, and all the losses that implies. Of course, it's easy to perform and quick, but well, you have seen the costs before. And now regarding continuous monitoring. Of course, it has a higher initial cost because it's an investment, but depending on the company, you can have CapEx, OpEx. So, I mean, you can talk about CapEx and OpEx expenditure system. We're happy to do both of them. So it's easier and you don't lose that much liquidity. But the advantages of doing continuous monitoring, what we showed you before, you see the complete life cycle of the asset. You can move from the schedule condition maintenance based system to a predictive and more proactive system. And also you optimize budget allocations, which is good because you don't have to move from investment to maintenance or from maintenance to investment. And well, this is it. Thank you very much for attending. Feel free to ask anything. I will be glad to solve it, or even my colleague. So I will wait for 2 minutes for you to ask. Well, there's more people joining now. We just finished the webinar, but feel free to ask any type of questions. What I can do to recap a bit is that compared from PD spot monitoring compared to continuous monitoring, well, you can find different strategies from doing nothing, expect nothing, just corrective maintenance system and solve each issue in the moment. But some fatal things can happen, as I explained before. You can do the site acceptance test, but in our experience, you are only, or you are capable of only watching or seeing 2% of the failures, especially in the infant mortality life cycle part. And compared to a continuous monitoring system, it can be around 13% of the cost. I mean, doing a site acceptance test is only the 13% of a continuous monitoring system. Then we can do spot test 6 times a year. And it's just 15, you can only see 15% of the failures in a total life cycle based on our experience. And it's also, about the 13% of the cost of a continuous monitoring system. Well, percentages increases, but here's the funny thing. Doing a temporary spot test once in a year, in a 30 years life cycle, once in a year, the cost compared to a continuous maintenance system, to a continuous monitoring system, skyrockets. It's a 78% more. You are just seeing the snapshot every year, 30 snapshots total. And the price is higher. Well, this is the advantages I showed you before. So if you have any type of question, please feel free to ask here in the Q&A corner. me or my colleague will answer. Or if you have any further questions, please note my email down, and I will be really glad to attend you. Okay, so we can wait a few minutes. We can wait for 4 minutes if you want. Okay, thank you very much for attending. Feel free to write us. We'll be really glad to attend you. Bye bye.